that you're familiar with producers, herbivores, carnivores, omnivores, and decomposers, let's take another look at how energy passes from member to member in food chains and food webs. There are more producers than consumers in an ecosystem, usually many, many more. This one rabbit can eat thousands of grass leaves in a single day. The energy flows from the grass to the rabbits. When an herbivore like a rabbit eats grass, only a small fraction of the energy in the grass is used by the rabbit for growing and reproducing. The rest of the energy is converted into heat and waste and is essentially lost from the food chain. That means if 100 units of energy are in the grass, maybe only 1 unit of energy is stored in the body of the rabbit and its offspring. That 1 unit of energy is what passes up the food chain to the next level of carnivores. Likewise, when a carnivore, like a mountain lion, eats a rabbit, only some of the energy in the rabbit's body is used by the carnivore for growth and reproduction. The rest is, again, given off as heat and waste. As you can see, the available energy goes down dramatically at each level of the food chain. The available energy gets smaller as you move from producers to herbivores to carnivores. The energy does not disappear. It just isn't available to be passed up to the next level of the food chain. In fact, much of the waste energy is passed down to the decomposers who break down animal wastes. A diagram in the shape of a pyramid is a great way to show how energy moves from one feeding level to the next in a food chain. A pyramid is wide at the base and narrow at the top. As you move up this pyramid from producer to consumer, the diagram gets smaller and smaller to show how less and less energy is available. That is why there are many, many more producers than consumers in any food chain or food web. Now it's your turn. Study the energy pyramid and select the best ecosystem member to fill in the blank spot. The choices are sea urchin, coral, hawk, shark. That's right. A sea urchin can eat plants and can be eaten by an otter. The sea urchin belongs in the second level of the energy pyramid. Is a sea urchin a producer or consumer? That's right, it is a consumer since it eats the seaweed. Since it is a consumer, is it an herbivore, carnivore, or omnivore? Well, in this pyramid, it is an herbivore, since it is shown above the producer level. However, sea urchins also eat animals like mussels and sponges, and they also can eat decaying matter like dead fish. That means you could classify a sea urchin as an omnivore, and in some cases, as a decomposer. Ecosystems can be complex. You may have heard someone talk about the balance of nature. Actually, the word balance can be misleading. Ecosystems don't reach a goal and then stay the same. They change a lot. In fact, each member of a food web experiences constant changes. The health of an ecosystem is a result of how successful the relationships are between the living and non-living members. In this forest ecosystem, the number of squirrels is enough to eat most of the acorns, but not all of them, so some acorns are left to reproduce oak trees.
The number of larger predators like foxes and hawks can be supported by the number of prey such as mice and squirrels. Too many or too few of any producer, consumer, predator, or prey can upset the ecosystem to cause overpopulation or famine, which can cause other changes. Nature's ecosystem management is a complex business. Many birds in this forest ecosystem eat insects. Swallows, swifts, warblers, wrens, bluebirds, scarlet tanagers, and woodpeckers are very important birds to the forest ecosystem. Without these insect eaters, insects would increase and eat too much of the trees, and some trees wouldn't survive. Here you can see some insect damage on this oak leaf. Trees like the ones around me are important because they're major producers in a forest ecosystem, and they provide homes for other plants and animals. Okay. We've learned a lot about food webs and ecosystem interactions. What types of ecosystems would be found where you live? What would be some of the producers? What about the consumers? What types of decomposers would there be? What would a food web look like of the ecosystem where you live? I'll let you think about those things while I enjoy a walk in the Harold Parker State Forest. Bye for now.